Hello, my calculus doing friends. I was asked to do a few problems as a review, so I thought I would video a few of them. And so these are from the review for Chapter 4. For those of you who are wondering what's going to happen, I'm going to email you guys the test or have the test up so that people can get the test on Tuesday at 1 o'clock. And then it'd be due 24 hours later, Wednesday at 1 o'clock. So that's kind of the thing. And then there'll be new videos and new notes and that kind of thing up for Chapter 5 for you to start after you're done with your test. So and start studying for Chapter 5. And then gosh, this semester is starting to come to an end, right? Okay, so I was asked to do from the review problem 4. Oh shoot, it's not hardly big enough for me to see here. How do I make it bigger? Yeah, it wasn't problem 4, it was problem 3. Sorry. Okay, so problem 3. I'm given this, that a at t equals 10 sine of t plus 3 cosine of t, and I'm also given s of 0 equals 0 and s at 2 pi equals 12. And they're asking me to find s at t, is what they're asking me to find. And it's an initial value problem. And so what I need to do is I need to take the antiderivative, because when I take the antiderivative of a, I'll get v. So the antiderivative, so I'm going to say here, antiderivative, right, of the pieces here. So the antiderivative of a is v at t, and then the 10 would hold still, and the antiderivative of the sine is the negative cosine of t, plus the 3 would hold still, and the antiderivative of cosine is positive sine. Plus, and then you can call that C1 or C, whatever you want to call that. And I'm going to rewrite this just because of the silly way I have that written. Pretty soon I'll think it's subtraction, right? Now I don't have a way of finding what C is because they didn't tell me what the velocity is, right? And so darn it, I'll just have to take the antiderivative again. So that's what I'm going to do of all of the pieces. So the antiderivative of v is s, and the negative 10 would hold still, and the antiderivative of the cosine is the sine, plus, and the 3 would hold still, and the antiderivative of the sine is negative cosine of t. The antiderivative of c is c at c times t. That's a constant right there, so c times t, plus, and then a new constant d. And so I'm going to write this because I have it written really silly. Oh, that's minus. I have it where my emails are popping up, and it's probably my algebra students saying, "What? Are you crazy?" Okay, now I have two conditions here, and luckily this one is zeros. And so since this one is zeros, I'm going to use it first because when you put in 0 right here for t, you'll actually be able to find out what d is, right? Because it'll wipe out. Now, if I didn't have the 0, so like if it said this was pi instead of 0, and so then when I put it in there for t, I would get pi, c times pi, then I would have to solve two equations, two unknowns to find c and d. And if you did the homework, you saw one like that. But this one, I'm pretty lucky because of having the 0. So when s at 0 is 0, so this is 0, equals negative 10 times the sine of 0, minus 3 times the cosine of 0 plus c times 0 plus d. Now, the sine of 0 is 0 as well, and c times 0 is 0. But the cosine of 0, be careful, is not 0. The cosine of 0 is 1. So this is 0 equals negative 3 times 1, so negative 3 plus d. So now we know that d is 3, right? And then now that we know that d is 3, we can use our other condition, which is that s at 2 pi is 12. So I'm going to come here and use this. So s at 2 pi, so I'm going to be putting in for s at 2 pi, for all of the t's 2 pi, and for s at 2 pi I'm going to be putting in 12. So 12 equals negative 10 times the sine of 2 pi minus 3 times the cosine of 2 pi plus c times 2 pi plus d, but d is 3. We found that out already, right? And sine of 2 pi is 0. Nice. And cosine of 2 pi is 1. So we get 12 equals negative 3 times 1 plus 2 pi c plus 3. And then nicely, the 3 plus the 3 goes away here. And I get 12 equals 2 pi c. And so when I divide by 2 pi, I get 12 over 2 pi equals c. And so I get 6 over pi equals c. And now I'm almost done, right? Now, they didn't ask me what c was. And in fact, c was something I came up with, right? And they didn't ask me what d was. What they asked me what to find was s at t. And now I can tell them what s at t is, because here is what s at t is, but remember it had c and d in it, so now I found the c and the d. So finally, s at t equals, and I'm just looking up there, negative 10 sine of t minus 3 cosine of t plus 6 over pi t plus 3. Almost didn't fit on my paper. I had to get kind of squinchy at the end, but okay, so that's kind of the story on that one. Okay, now the other one that I was asked to do by someone was sorry, I should have had the problem number written down. I just looked at what the problem was, and was number 30 from the review. So this is the Chapter 4 review, and number 30 was the other one I was asked to do. The integral of 4 to 8 of x square root of x minus 4 dx. And they're asking me to evaluate that integral. And so I can't take the antiderivative of that. Oh, it's blinking in and out. If I put that, if I put something, it for some reason will focus then on that. I don't know why. Okay, so anyway, long story short, I can't take the antiderivative of the pieces because it's a multiplication. And so I'm hoping that I can use the unchain rule whenever I have a multiply that I can't multiply together. Now, if I can multiply this together, it'd be great. But I can't multiply this together because I have the square root of a binomial. So what I'm going to do is I'm going to this is my plan. I like to write my plan. Will that make it, it has to be on there, doesn't it? So you can see the words, so we're going to have something to focus on. That's so crazy. u equals x minus v. I have a, and then du equals dx, right? 1, the derivative of x is 1, the derivative of 4 is 0. So this is just written in differential form, it's just dx. Now, I also have a plan for my bounds. So I have my low bound, which is x equals 4. And when I put this in for u equals, it's going to be 4 minus 4. So u equals 0. So my new bound is 0. And my up bound was x equals 8. So u equals, remember I'm going to put in for x, 8. So 8 minus 4 equals 4. So my bounds are going to go from 0 to 4. And I didn't have anything that's going to get rid of this x right here. And so, and you can't take the derivative with x's and u's, but I'm going to replace here x minus 4 with the square root with u, so it'll be the square root of u, and I'm going to replace dx with du. And what I need to do here is I need to replace x with something that has u in it, and I didn't have any direct replacement for it, but I really do, because u plus 4 equals x, right? And so I can replace that right there with u plus 4. So this is going to be the bounds u to 0 to 4 of u plus 4 times the square root of u du. And this is backwards. Usually you would write monomials first. And so, not that I would want to have to write this again, but I'm going to, because that makes it really nicer for people who are kind of struggling with their algebra a bit to realize that I can multiply this together, because it's a monomial times a binomial. And so the difference between what I started with is something that I could not multiply together. Now that I've used the u substitution, I can multiply that together, and then I can integrate the pieces. So this is going to be the integral of 0 to 4 of, I haven't taken the integral yet, so I'm still writing the integral sign. Come here, my little focuser, right? And so this is u to the, this is 1/2 plus 1 is 3/2, using the 4u to the half, and du. And now I'm going to integrate, and so I'll stop writing my integral symbol. So when I take the antiderivative of this, this is add 1, so that's going to be u to the 5/2, and divide by 5/2, but that's the same as multiplying by 2/5, plus, and then I'm going to, the 4 holds still, and I'm going to add 1, so that's u to the 3/2. And I'm going to divide by 3/2, which is the same as multiplying by 2/3. And I'm going to evaluate this from 0 to 4. And I'm not going to go back to x. X went from 4 to 8. And I could go back to x if I wanted to, and I would have to change these bounds from 4 to 8 in doing so. But that's going to be a lot more work, because then I'll have this, you know, instead of having just plain old u, I'll have x minus 4, and then I'll plug it in, but it would be exactly the same. So this is going to be the up bound, so that's 2/5 times 4 raised to the 5/2, plus, let's see, that's 8/3, and then 4 raised to the 3/2, minus the low bound, which is 2/5 times 0, that's 0, right? The rest of that is 0. So I only really have to worry about the up bound and what that's going to be. And so I just plug that all into my calculator, is what I did, and I got 512 over 15. Okay, so that was that problem there. And so that was a good one there that we did, and that was one I was asked about doing. And there was one more that I was going to do. It was number 37 I was also asked to do. The person, when they asked me about 37, so this is from the review, said they weren't sure what the U substitution should be. And so that was the question that they asked, that they had tried different values for U, they said, and it wasn't working out. And so the story on this is that a U substitution won't solve it. What you need to do is you need to divide, and since it's divided by a monomial, luckily I can. I need my focuser, right? I don't know why. It's so crazy. Sometimes it does better than others. Just doing my best with the equipment that we had on hand, since the school provided no equipment. And so anyway, so that's my story on that. And so my very old video camera doesn't seem to be having focus issues on this today for some reason. So now I can divide that, and so this is going to be the integral 3x, and then x squared divided by x squared, so this is minus 6. And then you don't want something in the denominator, so I'm going to write this as 5x to the negative 2 dx. And now I can take the integral of the pieces. So the 3 holds still. I add 1, so it has a 1, so that's 2, and divide by the same darn thing. Minus, and then the antiderivative of a constant is just the constant times x. And then I'm going to add 1, so the 5 holds still. I'm going to add 1, and I get negative 1, and I divide by the same darn thing. And then it didn't have bounds, so I need plus c. I'm going to write this as 5 over x. So minus 5, so 5 divided by negative 1. I feel like I got to get a little neater there. And then plus c. So students always ask me, how many points would you take off if we forgot to put plus c? And I'll tell you that the people so this is how people always do it, right? When you're in elementary school, they say to you, you're going to have to act a certain way because when you get to junior high, yada yada. And then your junior high teachers say, you're going to have to act this certain way because when you get to high school, yada yada. And when you're in Math6A, the teacher will tell you, you have to act a certain way because when you get to Calc 2, they're going to take off a bunch of points if you don't put plus C. And so you have to really be careful and know that you need the plus C. My son Tyler has a story of forgetting to put plus C when he was in Calc 2, of course. This happened to him because that's where it really gets rough, right? And that was the only thing he missed on the test. So he was really proud of himself. He had worked really, really hard and he forgot to put plus C. Oh, he was so angry about that plus C. And so some of his friends in the class started calling him plus C as a little joke until Mr. Greenwood could take it no more. I mean, it was now mid-semester and he was still being called plus C. And Mr. Greenwood said, Tyler, you got to tell him, he was giving him all kinds of advice on what he needed to say. Grade book, yell grade book at them because, you only missed the little plus C, wasn't that many points off, but it is some points off, so be careful. That was a dumb joke. That was a dumb story, I know, but it was funny to me. Anyway, okay, don't hit the like button if you don't like my stories. I don't even care if you hit the like button because I'm just doing my best. You know how that goes. What was the other one that someone asked me? I know there was one more that I was going to do. Oh, heavens. What was it? Wasn't an initial value problem. I should have wrote these down. Oh, it was 46. Now, what they're asking me to find here is g prime. So they're asking me to find the derivative of g at x. And I could potentially find the integral of that. I think the only way that I could find the integral of that right there would be to write it 8 times and multiply it all together. And then I could find the integral, and I could do the top bound minus the bottom bound, and then I can take the derivative of that, and then do a whole bunch of factoring too after that, and get the answer. That would be a way of doing it. It would be the long way of doing it. What I need to realize is that, oh, they've asked me to find the derivative of an integral, and that's the fundamental theorem of calculus. Fundamental theorem of calculus, part 1. And so what I have to make sure of is that I have a constant on the lower bound, which I do, and that I have x on the upper bound, or something involving x. So I could have sine of x, or I could have 1 over x, or x squared, or whatever have you. And I do, so that's great. So I take the derivative of this, so that's g prime at x. And then how you take the derivative of the integral according to the fundamental theorem of calculus part 2, when you have a constant here and the variable x here, is you just stuff in for t what you know about x. So this was going to be x minus x squared raised to the 8. And then you take the derivative of this top bound and multiply it right here, because it's a chain rule, which in our case is only 1. The derivative of x is 1. And so my answer is just this. And I'm all done. So there we had that. We did a lovely job on it. People always ask, are you going to put one of those on the test? They're so odd and whatnot. And fundamental theorem of calculus. Yes, there will be one of those on the test, right? Makes sense that there would be one of those on the test. Okay, I think that there were just 4 that some people had sent me an email about, and I said that I would make a short video on them, and so there's my short video on them. And so I'll get this loaded and see you guys in Zoom.